let's go through and show a couple of these mechanisms. You don't have to memorize these mechanisms. I just kind of want you to have an appreciation for, number one, sort of the elegance of these proposed pathways. Also, you know, I could tell you that the water makes a difference, but it would be nice if you could actually see why. Also, when you're looking at the proposed mechanistic pathway, you get to see what happens to that hydrogen on the carbon that bears the hydroxyl group. Why doesn't a tertiary alcohol undergo an oxidation? So let's do a couple of these mechanisms for primary alcohols. Okay, so we are going to draw out just a generic reaction for the oxidation of a primary alcohol with PCC in methylene chloride. So here's something that you might be interested in. It's kind of a big deal to notice what the solvent is when you're looking at a reaction equation. You know, a lot of times the solvent doesn't actually partake. Well, that's not totally accurate. It's the solvent's choice is a big deal. But when you're actually looking at the business end of the reaction, often the solvent doesn't actually participate. But sometimes it can. In this case, it's not going to, so I don't want you thinking I left it out somehow. I'm just going to show you the business end of a fairly generic primary alcohol. What I need to do, though, is I need to take that R and I need to pull a methylene out. So instead of ROH, to show you that, because I'm going to be using the carbon and the hydrogen that's on it, we'll say R CH2OH. So there's my alcohol. And I'm going to add this to some PCC. So pyridinium chlorochromate. We haven't done amines yet, but pyridine is, let me draw this a little more suggestively here. We'll put it over here. So pyridine looks like this. And in this particular, so that was pyridine. Pyridinium looks like that, right? And the chlorochromate part of the molecule looks like this. So see how we have a little salt here? And then we've got the rest of the molecule there. So there's PCC right there. So let me draw that in. This thing is PCC. This is pyridinium chlorochromate. So it's a salt. And we're going to attack the chromium with our alcohol. So we're going to take our electrons, our lone pair of electrons on the alcohol. Imagine that they're there. I'll draw them in a sec. We're going to attack the chromium, and we're going to delocalize electrons up like so. So these are the electrons that I used. Imagine that these are all here. You don't often draw them all in unless we're using them, right? And what you'll get is this complex here. So CH2, and then I'm going to draw this out a little bit. So O, and then still the hydrogen is there. Positive charge, right? Now, this oxygen, notice how it attacked the chromium. So I'm going to have to draw that, right? It's attached now to the chromium. What happened, though? We delocalized electrons up into that oxygen, right? And I'm going to abbreviate the rest of, and do it like this, so we don't have to draw out the rest of that piece of the molecule. And the chlorine is on here. So I drew this rather suggestively so that you could see you can take the lone pair of electrons from this oxygen and protonate, right? So we're going to take the hydrogen off of the oxygen that was on the alcohol. So it's already starting to look a little bit less like an alcohol, right? And what do you get? So when you draw this back out again, CH2. Oh, now both of the lone pairs are back on that oxygen. We're still attached to the chromium. Be attached to the chromium for a little bit. OH. Got the rest of this going on here. So O, and then the pyridinium ion. What I can do is I can delocalize these electrons, and when I do, I kick off chlorine. So notice how nothing has happened quite yet to our alcohol, but now something will, right? So we kicked off the chlorine. We've got the rest of our species here, and over here we've got our little salt. So we're going to attack that hydrogen, and when we do, now you guys, this hydrogen is the hydrogen that's on the carbon that bared the hydroxyl group. This is why a tertiary alcohol is not going to oxidize. There's no hydrogen there. I'm using that hydrogen right now. And what I'm going to do when I grab that thing is I'm going to put these electrons up here between the carbon and the oxygen, and I'm going to deliver those electrons to the chromium and then delocalize up into that oxygen. This is like dominoes, right? So what do you get? You get, now, what did I just do? We just covered this in the last chapter. You watching that? We're taking that hydrogen off. So that'll be a bold choice there. Let's use yellow. So we're going to take that hydrogen off, right? And then we're going to form a double bond here, right? And we're kicking this off. What did we just do? We just did an E2 reaction, didn't we? All right. Well, we did. And so now what do we get? We got what? Double bond to the oxygen. I'm just drawing it a little bit differently. It was on its side before. What is this thing? This is your aldehyde. You know, and the rest of this is going to go through. So your negatively charged oxygen, right, on the chromium is probably going to deprotonate your hydrochloric acid. You get a bunch of, a couple of byproducts out of this, but really what you care about at the end of the day is your aldehyde. And so we have taken the carbon of our primary alcohol up to the next oxidation state. That is the carbon that was oxidized. So there's no water in here to cause any trouble, right? If we had water in here, we might have had a bit of an issue. So the water actually, in the other mechanism, takes part in a couple of different spots. But, you can attack an aldehyde with water. Water can be nucleophilic, and so it can be a bit of a bother, right? Or if you would like to oxidize your primary alcohol to a carboxylic acid, it can be a nice thing to have. You'll also take this thing through an E2 process, sort of like your home run reaction. But what if you wanted to take your primary alcohol up to the carboxylic acid and not just stop at the aldehyde? And you wanted to use Jones reagent to do it, because that's what your book gives you for an example. So I can take my same primary alcohol, and we're going to do that down here. So I'll take my R, and then CH2 is my primary alcohol. Again, so what's really the business end of Jones? So we're going to take our Jones reagent, and for that I'm going to use this chromic acid. So this is like the ecologically unfriendly cousin of sulfuric acid, right? So we've got here's our structure, and this is in water, right? So I'm going to go ahead and I'm going to use the lone pair of electrons on the alcohol to attack the chromium, and we're going to delocalize electrons up into that oxygen. And so we've now bonded our, let me spread this out, our alcohol here to the chromium. And we have this little species going on. I just rearranged some of the groups over there just to make it a little clearer to see. Water is going to come in because this is going to be, so this is going to be with some water. Water is going to come in, and we're going to steal that hydrogen off of that oxygen. And what do I get? So I'm going to get, let me draw this out a little more suggestively. Well, we've returned the electrons to that oxygen, and turn this upside down so that it's a little easier to see what's going on. You can probably imagine what's happening next. Okay, so now what are we going to do? We're going to take that hydrogen off. Now that's that carbon, right, that was on the primary alcohol. That is, the hydrogen on that carbon doesn't exist on the tertiary alcohol. So again, another reason why you're not going to be oxidizing the tertiary alcohol.